Rules of the game. The rules of the game is you do not go across the equal sign with any part of the equation. So I can't move the secant of squared to the right or the tangent of squared to the left or the tan or cotan. I can't do that. But if I don't see a way out, I change things to cosine and sine. You're going to be using the top left corner of this sheet at the beginning a lot. And then we're going to keep expanding and adding. But at the beginning, we're using this top left corner. So all the way down to the Pythagorean identities. And the Pythagoreans are really important. So what I want to do first, I'm going to leave anything squared alone for now because it's going to clean up in a minute. So I'm going to leave that secant squared of theta alone. And I'm going to change tangent to sine and cosine. Well, tangent is sine over cosine, if you look at the top of your sheet. And cotangent is cosine over sine, right? And they're being multiplied together. And this is the simpler side of the equation. So I'm going to make the left side look like the right side. When you're verifying identities, all you have to do is make one side look like the other. Well, tan squared, there's not much I can do with that, so I'm going to leave him alone, okay? Well, now I've got, what happens with the sines on this right side here? And the cosines, what happens? They cancel, and these cancel. So everything cancels, you leave a 1 in its place. So secant squared of theta minus 1 equals tangent squared of theta. Now I want you to look down at the Pythagorean identities. Look at your book at the tangent squared plus 1 equals secant squared. What would happen if you move that 1 to the other side? What would it really say? Secant squared? No, well, tan squared plus 1 equals secant squared, but you're moving the 1 to the other side. What would it say? Tan squared equals secant squared minus 1, right? Well, then this is equal to tan squared equals tan squared, and I have arrived. Okay, so this guy seems like the simplest guy. So what I'm going to do is make the left side look like him. And I don't see any secants or cosecants on the left side, but I do see a fraction. And who does the denominator of a fraction belong to? Does it belong to just the 7 sine of theta or just the 5 cosine of theta? Belongs to both of them. So I'm going to rewrite it as, give it to each guy and put it as 2 fractions. So it's 5 cosine of theta over sine of theta cosine of theta. Because when you add fractions, you leave the common denominator alone and then you just add the top. So I'm just going kind of backwards, okay? Well, what happens in this first fraction? What happens here? What can we do? Can anything be done with that first fraction? Do you see any opportunities?
Cancel the sign.
The signs can cancel. And we have 7 over cosine of theta. And here the cosines can cancel. And we have 5 over sine of theta. Well, when cosine's in the basement, we can bring them upstairs. Who's cosine's cousin? Secant. So this is 7 secant of theta plus 5. Who's sine's cousin? Cosecant, right? And isn't that equal to the guy up there? So I see sine over cosecant. So if I have sine of A, cosecant is 1 over sine of A. And then if I have cosine of A, secant is 1 over cosine of A. Well, when I divide by a fraction, it's the same as multiplying by its reciprocal, right? So this is sine of A times sine of A over 1, really, because I'm flipping him upside down, plus cosine of A times cosine of A over 1. Does everybody understand what I just said? That ends up being sine squared of A plus cosine squared of A. And when we square a sine or a cosine, we don't put it next to the A, we put it in between the sine and of the A. And it's the same thing as sine of A squared. But they don't write it like that. They write it as sine squared of A, just so you know. So now we have sine squared plus cosine squared. I call sine squared plus cosine squared the Mickey Mouse of all identities. Look at your Pythagorean identities and look at the very first one. That is something you should ingrain in your head because that's equal to 1. You see that?
Wait, which one?
Sine squared plus cosine squared is equal to 1. Look at your first identity.
Okay.
And cosecant squared minus cotangent squared, if you look at that, if you move the cotangent to the other side of the third identity, you see it? Cosecant, when you move this cotangent to the other side, is a minus on your identity sheet. You also get 1. So 1 equals 1, and you're done. Here you convert secant of A to 1 over cosine of A, and cosecant of A to 1 over sine of A, right? Well, how do you divide fractions? You take keep, change, and then flip. So it's going to be 1 cosine of A times sine of A over 1, right? Well, that's equal to sine of A over cosine of A. What's sine of A over cosine of A?
1.
No. So here, obviously, you're going to make the left side look like the right side, because to make the right side look like that mess is going to be a little bit talent needed, right? So what kind of strategies can you see we could do here? There's different ways to attack this. Yes, we could FOIL. So let's do this. This is going to be sine of theta tangent of theta plus sine of theta secant of theta minus tangent of theta minus secant of theta. Let's see what happens here. So with sine and tangent, we can change everything to cosine and sine. So we can have sine of theta times sine of theta over cosine of theta plus sine of theta times 1 over cosine of theta minus tangent of theta minus secant of theta. Yes? We'll convert the tan of theta to sine of theta over cosine of theta, and secant is minus 1 over cosine of theta. I'm going to clean up each of these fractions and see what happens here. We have sine squared of theta, because sine times sine is sine squared over cosine of theta, plus sine of theta over cosine of theta, minus sine of theta over cosine of theta, minus 1 over cosine of theta. Well, what happens to the middle two terms? They're the same but opposite signs, right? These two go away. You see how that's just 0? Because you have a positive and a negative, and they just make 0, right, when you add them together. So now we have sine squared of theta over cosine minus 1 over cosine of theta. And since you have a common denominator, you can express it as sine squared of theta minus 1 over cosine of theta. If I look at my sheet and I have sine squared of theta minus 1, well, look at this. If I know that sine squared of theta plus cosine squared of theta equals 1, well, if I move this 1 over here, I get sine squared of theta minus 1. And if I move this cosine over here, I get equals negative cosine squared of theta. Because I had to move it over the bridge, it has to change signs. So look at this. That is equal to negative cosine squared of theta over 1 cosine of theta. And one of the cosines goes away, and that equals negative cosine of theta. We have arrived.